Well, hello, good evening, and welcome everyone to tonight's Fireside Chat at the Good Food Institute. My name is Ilya Sheyman. I'm the CEO of GFI here in the U.S., based outside of Chicago in Evanston, Illinois. And just such a treat to have this call today, this opportunity to have a real informal chat with person I'm talking to in a sec, who I'll introduce, as well as with this incredible community of supporters and donors and folks who are invested in GFI's mission of building a more just and sustainable food system and a world where all proteins are no longer alternative. So our hope today is to have a fireside chat with Dr. Liz Specht, who you can see on the screen. Liz, as she'll share in a little bit, has been with GFI, with the Good Food Institute, for nearly 8 years now, and is about to depart on some future adventures of her own. And so we thought this was a perfect opportunity to ask Liz to really reflect on the status of our mission, of how far we've come on our work to build a future where alternative proteins are no longer alternative, and the path forward and where we are, and to really get her perspective on the state of the science, the state of the open access R&D ecosystem, and really the state of the project of being able to feed 10 billion people sustainably. So the format here is I have a set of initial questions I plan to ask Liz throughout this call, but our hope is to really have an engaging conversation and to invite all of you who are watching and listening to participate as well. So rather than having a formal Q&A at the end, if you have any questions at any point throughout, please do submit them in the chat. We will do our best to work them into the conversation naturally. And if there's questions that can't be answered, we'll make sure we get some follow-up at the end. So please do send in your questions. Don't feel like you're interrupting. We're eager to really make this as much of a conversation as possible. So with that, Liz, do you want to maybe introduce yourself briefly and then we can dive in?
Absolutely. Thanks, Ilya. It's really great to be here with all of you. As Ilya said, I've been with GFI for almost 8 years now. I was one of two scientists who first joined GFI when it was just getting launched in 2016. And I am dialing in from a tiny little mountain town called Nathrop in Colorado. And yeah, really excited for this conversation.
Wonderful. Well, let's dive in. So let's start at the beginning. So how did you first get involved with GFI? And coming, nearly 8 years later, how do you see GFI's role in the space now?
Yeah, so I've always been interested in biotechnology and also had always kind of a sort of altruistic slant to what I wanted to do in the world and how to improve quality of life. And that originally in kind of my academic research path had drawn me into the global health space as seeing a lot of opportunities to use biotechnology to kind of address low-hanging fruit to improve how people are living around the world. And it was actually at some point in my postdoc that I sort of went down the industrial animal ag rabbit hole and started learning more about all of these myriad impacts of animal agriculture, not just on global health, things like pandemic risk and zoonotic disease and all of those, but also the impacts on the environment, on animal welfare, on food security around the world. And to be honest, I didn't really see a kind of science and technology lens to addressing a lot of those issues until I sort of stumbled upon GFI as a brand new organization at that time. And being exposed to this theory of change was really sort of a light bulb moment for me, realizing that we can approach solving some of these challenges in the food system in the same way that other technology-driven solutions have really changed the rate of progress in other fields. I mean, we always talk about parallels to renewable energy and electric vehicles, things that feel like one path is changing policy or changing consumer behavior. There's this parallel track that works synergistically with those efforts of developing technological solutions that make those behavioral changes much easier. So kind of approaching this from a science and technology lens, we're really talking about lowering the barrier to entry for folks working in this field and helping to make sure that resources are being used efficiently across the field rather than letting all of this happen in the private sector and letting the sort of invisible hand do all of the heavy lifting here. In terms of the role that GFI plays in this sector from the beginning, and this role is kind of constantly evolving as the space evolves. And that's one thing I love about the way that GFI works in this field, is that this is really a kind of unique model for us being able to serve in this field catalyst role and really looking across the whole landscape, all of the other stakeholders and actors in this space, and figuring out, what accelerates the entire alternative protein field that none of these other actors are necessarily incentivized or resourced or equipped to do. And that's sort of the way in which GFI acts as this rising tide to elevate the whole sector. And I think this model feels pretty underutilized across other fields. So I think it's a really exciting one and a really powerful way to tackle this challenge. And this is really kind of baked into the DNA of GFI. Of course, I should also say, GFI has this global footprint. We've got our 6 affiliate organizations around the globe. And the way that we're able to take on this work that other actors and other stakeholders don't take on is because we are a donor-supported nonprofit where we kind of only answer to impact. And staying aligned to our mission. So that's a really unique space that we fill, and it makes me incredibly grateful that we've got this community of donors. I know several folks on this call are already donors, folks who might not be donors yet, but really it's that element of what powers this engine of our work that makes that really unique role that we fill possible in this space. So kind of, stepping back and just looking at what's transpired over the last 8 years, there's kind of 2 observations that seem on the one hand contradictory, but both seem extraordinarily true. One is that we have accomplished in these almost 8 years far more than I would have thought possible. If you were talking to me in 2016, I would not have predicted that the field would be this much further along because it was so hard to get traction in a lot of ways in those early years. But at the same time, there's still a lot of work to do, and this is really just the beginning. And we're starting to see the fruits of some of those early efforts and early relationships that we started forging really kind of, come to fruition in the last few years here, which is super rewarding.
Great. Well, so, when we talk about alternative proteins, we're really talking about essentially 3 categories. We're talking about plant-based meat that mimics the taste and texture of conventional animal meat, but made from plants and plant inputs. We're talking about fermentation-derived meats, sometimes with that is an ingredient on top of something else. And we're also talking about cultivated meat. So meat made from animal cells, real animal meat without the animal. I think based on some of the questions we've gotten thus far, it might make sense to kind of take this pillar by pillar. But why don't we start with something that's been in the news a lot, which is cultivated meat. Now, I understand, and this was before my time, that when you joined GFI 8 years ago, you started out with some skepticism of the viability of cultivated meat, that is meat grown from real animal cells, but without the animal, as being a viable, scalable solution to alternative seeds. Can you talk about why and how your thinking has changed over the years?
Yeah, this is kind of funny to reflect on in retrospect. So I came in not with a little skepticism, but actually with a lot of skepticism about really the economic viability question and the scale question. And I think that skepticism was coming largely from the fact that my familiarity with animal cell culture, which is really, the foundational technology of cultivated meat, was really coming from this academic realm. And certainly that's true of many folks who are now working in cultivated meat, where things like the cost of the reagents that you're using and all of the plastic waste that goes with the process and contamination risks because you're taking petri dishes in and out of incubators and handling them a lot. It just struck me as nonsensical that this could be scaled up at the scale of industrial animal agriculture. And really, I think what has unfolded over the first several years coming on board was really kind of chipping away at the assumptions that I was bringing around those sort of standard practices or protocols in an academic research context, and whether those necessarily need apply to a much more standardized kind of larger operational environment. And really looking at how animal cell culture is already being done for a number of biomedical applications, things like cell therapy and antibody production and so forth, that I was coming in with not a ton of kind of hands-on familiarity with, and recognizing that a lot of those quote unquote best practices are just sort of the way that it's been done in the past. There's sort of this inertia in academia to not mess too much with the system when you're really trying to study, some aspect of cell biology or what have you. So it was really kind of delving into what those hurdles were and seeing where there are already solutions that have been deployed, and then asking that question of, is there some basic like physics principle or fundamental that can't be overcome here? And time again, the answer to that question was no. There's plenty of possible approaches that could allow us to get over what originally looked like these barriers or challenges. One of the big first eye-openers, particularly from a cost reduction perspective, was kind of cracking open what's in the cell culture media for animal cell culture, and specifically for what the types of cells used in cultivated meat would require, and really kind of looking line by line in those ingredients, and figuring out what would these cost curves look like as we go to scale, as we move to food grade sources, as we kind of rethink this from the perspective of applying animal cell culture to meat production as opposed to some other kind of much more high value use case in the biomedical realm. And that was one of the first white papers that we put out as an organization, was that media cost analysis. And we've heard since then that multiple academic labs and multiple companies have basically kind of used that stepwise scenario analysis as a bit of a playbook and really proven out those assumptions. So it's super exciting to kind of see that being put forth as sort of hypotheticals, and then now over the last several years, seeing people really kind of validate those hypotheses. Another thing that's been, I think, really influential in bolstering my confidence in the viability of this ultimately going to scale and hitting price parity is just looking at the caliber and the number of scientists, really well-reputed scientists who have entered the cultivated meat field over the last 8 years, as well as the rate at which they stay in the field. So, you'd think if there's kind of nothing under the hood, folks might join cultivated meat when it's, a hot topic and getting a lot of venture investment, but then they might go back into, a biomedical company after that. But that's not what we've seen. And actually, one of my colleagues, GFI principal scientist for cultivated meat, Ilya Sheyman, pulled together a great Twitter thread on this of kind of documenting the career paths of multiple scientists who have really strong reputations and have a lot of, kind of professional heft behind them, who have entered the field and are staying in the field, not kind of reverting back and becoming skeptical. So that gives me a lot of confidence as well.
Wonderful. And, it's striking that your own journey kind of mirrors what we're seeing out there in the market. 8 years ago, cultivated meat was largely science fiction. You had 10.5 years ago, Dr. Mark Post unveiled the first cultivated meat burger for $300,000 or so, depending on the exchange rate for one burger. And now fast forward 10 years, suddenly you have cultivated meat, at least briefly, for sale in Singapore and the United States. You now have 3 companies that have gone through a regulatory process to serve to customers. That's an incredibly short period of time. And at the same time, having more than 100 companies work on cultivated meat, academic institution after academic institution, picking up the science and figuring out what are the critical blockers that move them forward. It is incredible to see that kind of drop in price and breadth of field and ecosystem building happen in really under a decade.
Absolutely.
Well, tell me, let's stick on cultivated meat for a little bit. So one of the questions that comes up is when you look at other industries, other examples of field building, we often talk about electric vehicles. We talk about solar panels. We look at decarbonization efforts as in some ways analogous, though we know food can be different. What lessons do you take looking at kind of the other endeavors of scientific field building that you think are relevant to this field of alternative proteins?
Yeah, I mean, I think some of my background, so in my PhD work, I worked in an algae lab kind of during the biofuels boom era. My specific research was not on biofuels, but I was very tangential to that field and very kind of clued in to kind of what we saw in that moment was looking at a huge influx of investment into a relatively early stage emerging sector that was coming out of the impetus behind a lot of that government investment into biofuels was a result of basically trying to provide stimulus for the financial crisis that was happening around 2008, 2009, 2010 was when a lot of this funding was rolling out. But kind of reflecting back on that, it felt like the science wasn't actually quite yet at a level that influx was really kind of appropriate because a lot of that funding was around scaling and commercialization. And there was still a lot of the sort of foundational bench scale R&D that needed to happen, maybe less so into commercialization at that stage. So I think that was a really interesting kind of example that you have to get the timing right for what types of influx of resourcing to an emerging field is happening. Is it more upscale R&D or early stage R&D, or is it more downstream commercialization and scale up? And that, if you don't get that right, it can make it look in retrospect, maybe like a bad investment, or, we saw some of the companies from that space sort of fail to launch. However, what I think is not always visible in those sort of non-linear progression of emerging fields is that the knowledge that's learned when a field is resourced at a high level, that knowledge remains. Knowledge is, I always like to say, knowledge is a one-way ratchet, right? So, a lot of work was accomplished, even if we didn't get to the point of, biofuels hitting price parity with commodity fuels, especially when the cost of oil went back down and that became a really hard bar to hit. That knowledge still exists. And so if or when there is another big push for something like biofuels in the future, that work doesn't have to start back where it was in 2009. We can build on top of the progress that was made there. I think another thing that's not always obvious is that a lot of those learnings, have informed progress elsewhere in the bioeconomy, and we're actually seeing alt proteins reap the benefits of some of those sort of side learnings that came from that push. So, there's still a need to invest aggressively, and that's always worthwhile, even though the public might not always see some of those more durable kind of behind the scenes impacts. And I think the learnings from that are really informative for kind of our strategy for helping to bolster this robust open access scientific and knowledge ecosystem for alternative proteins to make sure that we're, as much as possible, trying to get this knowledge out there, open access, not have it all go immediately into the private sector, and to sort of position this field for, being kind of ready to absorb those types of influxes of funding, and kind of be in the right place at the right time when some of these broader winds shift in the right direction. And that, again, to go back to kind of our ability to operate in this way because we have gifts from donors that are really interested in supporting this entire field. We're able to be kind of slowly building this foundation such that it's ready to absorb much larger levels of investment. And again, we're seeing alt proteins called out in things like the White House executive order on biotechnology and biomanufacturing, and kind of feeding into this broader push towards leaning into economic competitiveness through bioeconomy. investments. So that's really, really powerful that we're able to answer some of those early basic questions that, again, might not sort of be candidates for work in the private sector just yet, so that we can capitalize on these other resource streams that are now starting to come our way in a much bigger way.
Right. Well, so you just started to talk about why people come to think about all proteins, to embrace alternative proteins. And we know that people's entry points differ. Could be someone who's deeply concerned about the climate crisis, could be someone concerned about nature and biodiversity loss, or zoonotic diseases, pollution and waste, animal welfare, you name it. There's a whole host of reasons people come to this work. One of the places GFI talks about this a lot is kind of, as you talked about, comparable to other sectors. And we talk a lot about transportation as an analogy. And I think it's interesting because the way we talk about the analogy to transportation really does look like a yes and solution. That clearly, if you think about transportation, we need more public transit. We need more walkable cities and protected bike lanes. And there is a critical mass of people out there who like to drive a car or need to drive a car, whether it's because they enjoy driving a car and have some sort of affinity with their car that they've had sometimes for decades, or because it's more practical, it's faster, or for other reasons. And so the electric vehicle is kind of not designed to solve every problem of the transportation sector, but it is there as a better option for those who want to continue driving a car. And I think we often talk about alternative proteins in that same way, that we know that 95% of people out there are consuming meat or want to be consuming meat. We've seen that every study for years has shown that demand for meat will continue to grow, maybe upwards of 50% by 2050. And so the kind of theory of change, the hypothesis is, if you can't change the demand side, you have to change how meat is made. You have to diversify the protein supply, find ways to make meat that is as delicious, as affordable, and meets other needs for people, whether nutrition or otherwise, so that they can embrace alternative proteins. Because ultimately it's food, right? We're talking about food that people put in their bodies to nourish themselves in all sorts of ways. So in that context, there's been some pushback, particularly on plant-based meat in the past couple of years. Sort of, is it ultra processed? Is it as good for you? You name it. Can you talk a little bit about kind of the reality of how plant-based meat, the kind of products that are out there, as well as potentially cultivated meat, compares to what it would be replacing, or what it would be displacing in people's diets? How does a plant-based burger compare to a burger it's replacing? Because that's really the question here, right? It's not how does it compare to a tofu or a tempeh. It's for somebody who's interested and eager to eat meat. How does the alternative protein stand in for that on nutrition in particular and perceptions of nutrition?
Absolutely. Yeah, it's a great question. And I mean, if we could get everyone to move to kale and beans and lentils in the next 10 years, like that would be phenomenal. But this really is the pragmatic solution for a drop-in replacement for or alternative to conventional meat. So, there's a lot of, I think, consumer misunderstanding or just kind of lack of knowledge around what is used by some of these terms, ultra processed. A lot of things get thrown into the same bucket, and we're starting to see more nuanced conversation around that. Around, clearly a Twinkie is not the same thing as a plant-based burger, and those health impacts will look different. And some of the bucketing systems, like the NOVA systems for processed foods, really are not necessarily well positioned to make those nuanced distinctions. If we're looking at nutritional profile, look at macronutrients and micronutrients, a lot of the plant-based products really are hitting the mark, and that's in part by design. And we're starting to see companies that are tweaking their formulations and creating multiple versions of products that kind of mimic the spectrum of healthfulness of conventional meat products. So, right, you've got 80-20 ground beef, you've got 90-10 ground beef. Now we're starting to see companies like Impossible and Beyond develop, healthier versions or indulgent versions. So really all of those questions of what do you want that macro profile to look like, we're seeing kind of matches like that in the marketplace. From a micronutrient perspective, again, you've got really kind of a lot of control over what that nutritional profile looks like in a way that you actually often don't necessarily with conventional meat. You sort of get the meat as it is from the animal that didn't evolve as a food source for humans. It evolved to be, a free living animal and is kind of serving its own needs in terms of what's the composition of its muscle tissue. That's actually one of the things that I find really exciting about cultivated meat is that we've got the opportunity not just to kind of exactly mimic the exact composition and nutritional profile of the meat products that we know and love and consume all the time, but there's the opportunity to produce healthier versions of meats because we've got kind of more fine tuning over the process. So for example, you could have a steak with higher iron content. You could have, a chicken breast that's got omega-3 content. There's a lot that kind of becomes in play in terms of adjusting nutritional profiles for cultivated meat that simply is not realistic when we're kind of constrained by the biology of the animal in a conventional meat system.
Great. So staying on this topic for climate change for a sec. So last fall, the UN Environmental Program put out a report on the potential benefits of alternative proteins, looking across plant-based, fermented, cultivated. We've seen folks do modeling on methane impact. We've seen modeling on land use, water, et cetera. Obviously, when it comes to cultivated, there's a lot of unknowns, and there will continue to be some unknowns until the industry gets to scale. But can you give your best snapshot on kind of what we know now about the climate, biodiversity, land benefits of plant-based and cultivated alternatives, and kind of what's ahead that we still have to learn?
Yeah, sure. And it's really exciting to see more and more studies come out in this realm, especially as we're starting to get kind of larger scale production processes underway where we can get a lot of that data. But I'll kind of step back at a high level and just kind of set the stage for why alternative proteins in any form are sort of a slam dunk from a resource use perspective, which does translate to not only greenhouse gas emissions, but land use, water use, fertilizer use, all of that really comes down to kind of the basic thermodynamics of, calories going into animals to then convert that into muscle tissue and eggs and dairy products versus using those inputs directly as kind of components in alternative protein products. So, within any biological system, it's pretty much across the board. About 90% of all the energy going into that system is getting burned off in the form of kind of basic metabolic processes within that animal. So we always talk about these sort of feed conversion ratios of 9 calories in to get 1 calorie of chicken out. For ruminant animals like cattle, that's closer to 30 to 1. And that is really because you're building, all of the parts of this animal, and this animal is walking and moving and breathing and thinking, and all of those processes is simply burning off a lot of those inputs. And so for alternative proteins, we're essentially going straight from crop in the field to a plant-based meat product. Or in the case of cultivated, those cells are metabolizing, but again, they're not having to do any of the sort of above and beyond functions that are needed to maintain a full living, breathing animal body or build any of the parts that aren't ultimately useful to us as food outputs or other outputs. So there's kind of that basic efficiency that's factored in that's roughly on the order of 1 order of magnitude more efficient. And we see that play out in the numbers that we're seeing in life cycle assessments across all of these products. So for greenhouse gas emissions, water use, other kind of environmental impacts like eutrophication, which is essentially, nutrient runoff going into our waterways and ultimately going into our oceans and causing ocean blooms, algal blooms in the ocean. Air pollution that's coming from particulates, from manure, methane and nitrous oxides that are coming from decomposition of manure. All of these things that go with animal agriculture either simply aren't a thing for alternative proteins. Again, there's no manure. There are some kind of side streams that come out of processes like fermentation or agricultural residues that are left over after you're fractionating plant proteins. But there are use cases for those side streams as well. But then some of those other kind of outputs of animal ag that do have pretty devastating environmental impacts are simply not a factor in these alternative protein production systems. And we are getting better and better data all the time, both from sort of aggregate, disinterested academic life cycle assessment studies, as well as studies that we're seeing put out more and more by individual companies on their exact processes and products, where they've got all of those very granular data inputs.
As you were talking, I couldn't help but think back to the video of our founder, Bruce Friedrich's TED Talk, where, he has the 10 bowls of spaghetti, and he's like, imagine you threw away 9 of these just to produce the one, right? That's the scale of what we're talking about the inefficiency in protein production, the way we're doing it. And as we think about a global population moving from 8 billion to 10 billion, and as we think about demand for meat growing 50% or more by 2050, we got to find new ways, better ways, more sustainable ways to be able to diversify the protein supply and feed all those people without burning the planet. So, you're a scientist. This is a tricky question to ask scientists because I know science is unpredictable, right? We don't know exactly what form it'll take, which innovation will happen. But when you survey the landscape, what are sort of the state change innovations that could break through the biggest unknowns or obstacles to cultivated meat reaching scale, to us reaching taste and price parity? We know the challenges lie ahead. We know we don't quite know, but what are the things that are unknown that could suddenly accelerate the timeline or make scale possible or make cost effectiveness possible more quickly than they would otherwise?
Yeah, you're right. We are kind of notoriously bad always in any field at kind of predicting the rate of scientific and technological innovation. And part of that is because you're not able to sort of look at advancement in any one field in a vacuum, right? Scientific advancement, there's cross-cutting technologies all over the place that can have these sort of feed-forward loops regarding the rate of progress in any field that we're interested in this case, alternative proteins. So advancements in those other fields can really change that rate of innovation and progress. So, some of the kind of maybe obvious, but worth saying anyways, because it comes up in every single conversation where folks are kind of doing technology landscaping and looking for these intersections between different disciplines, is I'm super excited about some of the potential on the horizon for us to more heavily leverage advances in computation and modeling and artificial intelligence and machine learning, both to accelerate R&D for alternative proteins, and that can be on the sensory side of things, or nutritional side of things, or ingredient sourcing, or plant or microbe breeding. There's kind of a whole realm in which computational and modeling and AI tools can help on kind of bench level R&D, as well as incorporating those tools into scaling and manufacturing and kind of building those into the process flow of manufacturing facilities that are coming online to make them more efficient and more adaptable, and to improve the ability of companies to kind of be nimble and make decisions about, different feedstock sources that they have access to or what have you. So I think those domains really might be able to kind of give us a step change in how quickly we're able to make progress in this field. One thing I just wanted to shout out, it was super exciting that earlier this week, the Bezos Earth Fund announced a $100 million commitment to grand challenges to leverage AI to advance key climate solutions. And alt proteins was selected as one of the areas in which they're launching one of those challenges. So that just feels like one of those incredibly powerful sort of intersections between scientific disciplines that has huge potential to accelerate progress in the field. I think another thing that's really helpful, again, because it sort of creates a sandbox for innovations from a number of different disparate fields to kind of come together at demo scale, is the notion of these sort of advanced manufacturing institutes or places that have the actual infrastructure to do pilot or demo scale runs of processes where you're able to take an innovation from, a lab in one university and a startup in another country and kind of put them all in one process and see, how you can get kind of synergistic effects between those different approaches, and what that actually looks like in a true commercial deployable process.
Excellent. Okay, well, I'd love to switch gears to your time at GFI and kind of some of the levers of the interventions we have. So when you think about, you talked about GFI as a field catalyst, you've been at GFI nearly 8 years. What kind of things was GFI, and I guess in particular, the science technology team at GFI doing in the early days, 8 years ago, that we've since passed along to others as we've stepped into this field catalyst role? What developments do you see in the kind of scientific academic ecosystem that others are taking on that make you optimistic for the future?
Yeah, there's a lot of things that we used to do hands-on that we no longer do hands-on, and that's kind of precisely sort of representative of this field catalyst model, right? Of doing things that no one else is doing in the moment and hopefully kind of capacity building across the broader ecosystem so that it doesn't need to be us serving that role forever. We're equipping and empowering other stakeholders to perform those functions so that we can move on to the next thing. So, one example that comes to mind was when I first joined GFI, I actually used to spend a fair bit of time doing kind of direct technical due diligence, particularly in the cultivated meat realm, because there was venture capital interest. Only a handful of cultivated meat companies, like literally could count on one hand. And there was no one who was really in a position to do that tech due diligence. If they went and found someone who had, done diligence for regenerative medicine companies, like they just didn't have sort of the right context to evaluate technology in the context of applying that for meat production. So we filled that gap kind of by necessity, and because the landscape was sort of small enough that a small organization like us was able to do so. Then we started seeing, of course, kind of a huge influx of new companies, new investors, and we were able to kind of over time build out a resource bank of other consultants that now, we had confidence, like really understood the sector, understood the challenges, understood like what technologies do and don't apply from a biomedical context to a food context. And then we were able to start to kind of more play matchmaker within that ecosystem that we'd built out, and point, investors in the right direction of consultants who could do that work for them. Another area in which this sort of phenomenon plays out a ton is in our research ecosystem building work and our kind of education and workforce development work. So obviously one of the big bottlenecks in this field is technical talent. So you have to start that in universities and get folks aware of this field and knowledgeable about it. And in the early days, there were no courses, no student groups, no majors, no minors around alternative proteins. So it was really us, GFI staffers, and I'm using kind of the royal us, because a lot of our international affiliates were pretty heavily involved here too. actually building that curricula, building the slide decks and syllabi, and in some cases launching and even teaching courses ourselves. It was actual GFI team members in the classroom. And that was really helpful at the beginning because it allowed us to be sort of embedded, boots on the ground, learning what the gaps are, what questions do people have, what pushback are we getting from universities around whether they want to launch this course, or which which university like course number does it get, what field does it, what department does it live within, those sorts of things. So we were able to really understand what those gaps and barriers were, and to figure out what needs to be pulled together to address that. Now we've kind of expanded that whole domain of work into being kind of in the realm of our alt protein project, which is our global student movement. So we've got chapters of alt protein project student-led teams at more than 50 universities around the globe, and expanding access to courses and curriculum is one of their kind of main charges. So they are sort of, in a fractal-esque kind of way out there doing a lot of that work sort of on GFI's behalf. And then our team is now able to focus on supporting and mentoring that program, as well as engaging with kind of a higher tier of educator communities. So, for example, engaging in professional societies for educators, and hosting a curriculum repository that anyone can come and access and contribute materials to. So we've kind of evolved into a stage from that sort of really on the ground type of work to now kind of sitting the layer above that, and equipping and empowering a whole cohort of champions who are really embedded in those types of educational environments, and are able to take that work forward.
Excellent. So we got a question in the chat, which is, what surprised you the most during your nearly 8 years with GFI?
Ooh, that's a great question. I think if you had told me even 4 years ago, let's say 5 years ago, that like cultivated meat would be approved by multiple regulatory agencies around the world and actually being served to customers, not in just a like tasting, you signed a liability waiver kind of format, I would be very surprised. And I think that was one of the kind of big potential, like total roadblocks that was possible in this field would be, especially in the US, where like the jurisdiction between FDA and USDA wasn't exactly clear. Like that could have just gotten gridlocked almost indefinitely. And so to see, agencies come together and develop, kind of joint oversight frameworks, and then to really work with each other to kind of learn, how should they be assessing safety, and how are other countries looking at this, and how can we help kind of support, flagging, what types of assays and evaluations are appropriate. That I think has been a very pleasant surprise from my perspective.
Great. So you talked kind of about roadblocks, bottlenecks. There's another question in the chat that says kind of, if this doesn't happen, what's it likely due to? One of the ways we talk about that internally at GFI is the idea that we're accelerating the transition to a world where all proteins are no longer alternative, that we're helping put our children to the wheel to advance the pace at which this happens. From your vantage point, what do you see as kind of the most promising levers to make that acceleration happen, to kind of de-risk the whole enterprise of getting to a place where we can sustainably feed 10 billion people without burning the planet?
Yeah, it's a great question. I mean, I'll say this a little bit tongue-in-cheek, but it's true. Like basically the most promising levers are precisely all the things that GFI is working on. And that's true not just in the science and technology domain, but in corporate engagement and policy. We are pretty strategic and pretty clear-eyed, I feel like, when we're kind of assessing like where can we actually, change the gas and the brake dynamic here. One of the big sort of overarching observations is that for any type of decision maker or stakeholder, again, whether that's a policymaker or an executive at a major, food multinational, or a researcher trying to decide like what field they want to lean into as they kind of progress through their career. If there are knowledge gaps, that's basically paralytic. So even to folks who might be incentivized to want to support alt proteins and to advance this field, if they don't have enough information to act on or to be able to kind of make that case internally at whatever their organization is, they're not going to get very far. So a lot of what GFI does is really kind of systematically filling those knowledge gaps on a number of different fronts. So again, I brought this up a little bit in the context of like regulatory, right? People have to really understand the cultivated meat process to be able to like understand how to regulate and assess safety. So serving as a knowledge provider there. We do it on the kind of corporate engagement and industry and market and consumer understanding front to equip and empower companies to be able to make decisions with clear eyes and a clear understanding of the sector. And then, of course, we do it on the science front. Another lever, again, and I mentioned this before, is around talent and people and kind of having enough champions who are sort of advocating for this across all of the different spheres that alternative proteins touch. So that's not just in kind of the student and academic sphere, but really kind of building out champions across the ecosystem, since we as a 200-ish global 200-ish person global nonprofit will never be able to do all of that work ourselves. But I think kind of thinking at a high level around what are the biggest risks and what can be done to address those risks. There's kind of two things that get in the way of the otherwise like quite effective invisible hand of capitalism, right? One of those is technical risk and the other is market risk. So I think a lot of what SciTech and the policy team are doing to get more resourcing towards that foundational R&D and to de-risk some of these scientific and scaling challenges, that addresses the technical risk piece of this. For the market risk, that's basically, do people want it? It is really difficult to kind of manufacture or guarantee demand, but I do think there's some pretty exciting kind of market shaping approaches around that that have been used in other sectors that I think could have a lot of impact in this field. So leveraging things like large scale procurement, working with folks who are kind of single decision makers, think of governments or military or multilateral agencies that deliver food aid, folks like that, where, there's kind of a single point of intervention to guarantee demand at a certain volume, can really move the needle on scale and therefore on cost. And then that kind of filters back to the private sector and what consumers are seeing, and can have kind of a two-way street influence on demand.
Yeah, I mean, it's striking. I know some folks on the call probably have heard about some of the small number of states that have been having these debates about, is cultivated meat ready for prime time? Should we hold off on allowing it in our state, et cetera? GFI has been kind of working closely with industry partners and others to push back against those, but I think with a lot of success, frankly, with a lot of states going, wait, we need to think about this more. One of the interesting dynamics that's played out is you've seen NASA, you've seen others in the government say, look, we need this R&D. We need these tools. We need this access. And so what's interesting is you're kind of seeing an affirmation from these stakeholders in the public sector of the importance of allowing the R&D to happen, allowing these products to get to taste parity and to technical readiness and price parity. And that's just really exciting, because ultimately we need to get these products to be at taste parity or better, at price parity or better, and meet consumer needs. And that's when we'll get to see the full force of the market, people actually being able to choose these products at a level playing field. Well, we're nearing the end of the hour, so let me ask you this final question, which is, as you're looking back and as you're looking at GFI's work now, and think about our vision for the future, a future where we can actually feed 10 billion people in a way that doesn't burn the planet, that doesn't require tens of billions of animals every year, that doesn't come with pandemic risk or zoonotic risk. What is most central for you as a source of hope, as a source of promise that this is really possible?
Yeah, I think, a lot of it comes from acknowledging that this is not a linear journey and that there's so many different sort of intersecting influences and things that we're tracking that we can really kind of see progress across multiple dimensions, even if there are setbacks or challenges. And that often a lot of the fruits of our labor might take a while to sort of come to fruition, but that we know that those influences are kind of creating ripples out across the ecosystem. So, for example, in the last year or so, we've seen probably greater traction than we have ever in my time at GFI in terms of kind of buy-in to the notion that we should be resourcing open access research and development in alternative proteins. We're seeing it called out in, reports from USDA to DOE to NSF. So that has felt really rewarding on the science and technology front, but that's also coming at a time that we've seen sort of a cooling or a stagnation on things like private sector kind of market demand, private sector performance, venture capital investment, some companies folding or being acquired by others. So these are all kind of curves that are, they're related, they correlate with each other to some extent, but there are ebbs and flows across that ecosystem. And so I think, to keep this sense of hope and sort of zoom out and be aware that yes, even though there's blips and there's kind of anomalies when we're really zoomed into one metric, when we zoom out, we do see that we're moving in the right direction. And the field as a whole can still advance. There's a concept that I love because it's one of those things where once you hear about it, you kind of start to see it everywhere, called Amara's Law. That's basically the principle that we're really bad at. We tend to overestimate how much technological progress there will be in the short term. So say in a 1 year time horizon. And we far underestimate how much progress there will be in, a decade's kind of time frame. So I think keeping that in mind and recognizing that you have to kind of zoom out and sort of find those signaling moments that really kind of give us confidence that we're making progress in that larger journey, rather than getting kind of bogged down in some of the day-to-day fluctuations in what this path looks like. Yeah, I think, we've experienced some new headwinds for the field this year. We've talked about some of the kind of pushback and critiques and sort of public discourse, policy interventions on the cultivated side. But all of that is to be expected for a food system transformation of this scale, which is really what's absolutely critical for us to achieve all of the potential that you mentioned, feeding a planet of 10 billion that doesn't put us at pandemic risk or climate catastrophe risk or any of those kind of looming challenges. And again, I think this is really speaks to sort of the power of GFI as this philanthropically supported model, that we are able to be kind of immune from some of those buffering influences that can really set back other stakeholders in the space, and makes this a really pivotal moment for, support for an organization like GFI that's developing this open access R&D ecosystem, helping to give public sector and private sector the confidence to continue deploying resources towards all proteins, and ultimately delivering products that get us where we want to go, and where we need to go to build a better future for the planet and for people and for animals. So a huge thank you to everyone on this call and who's part of this journey with us for making this possible, and for equipping us to continue to be this sort of rock within, this rapidly evolving ecosystem.
Wonderful. Well, thank you so much, Liz, for not just 8 years of doing this work, but for sharing these thoughts and for everything you will continue to do for people, for animals, and for the planet. I do want to say I'm struck, we introduced you as the Senior VP of Science Technology, but the way you talk about the special sauce for GFI, which is really this flywheel between science and technology, policy and corporate engagement. And I want to end by just reiterating what you said at the end, which is a thank you to our incredible global community of donors and supporters who make these activities by GFI and make all this impact across our 6 global affiliates possible. We could not do this without you. And this work is really intended to transform our food system, to build a more just, secure food system, one that's sustainable for people, animals, and the planet. So thank you to everyone. If you had a question that wasn't answered in the chat, or you're coming off this call and coming up with another question, please do just email us at philanthropy@gfi.org. Again, it's philanthropy@gfi.org. And we'll work to get back to you soon with an answer. And mostly just thank you. Thank you for all you do to advance this mission of building a world where alternative proteins are no longer alternative. And just wishing you all a wonderful rest of your day or night, depending on where you are. Thanks so much.
Thank you.